Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about code converter. So first thing I am taking this program binary to hexadecimal. There is a packed number to unpacking the numbers that we are going to do it. So first we can start the program org0h. So the program will be compiled at the location 0h. So first instruction move a comma hash 5ah. So this is the number I am going to take this number as an input. I am going to perform a hexadecimal. So that's this is a very simple thing. I am taking this number 5a is an actual value. I am going to split the numbers. That is this is 5 no and this is a. So that is how many tens will be available, how many ones will be available. So that will be I am going to convert the values. Look at this. I am taking a copy of this number, move b comma a. So this 5a will be copied to b register also, because the accumulated content will be overrated whenever you are use some operation. So if whenever you are add a number or a subtracted numbers, what happens? Automatically the result will be updated in accumulator. The accumulator content will be lost. So that's why I am taking a one copy of this number to b register. So whatever you are giving in input, that will be available in accumulator. After this instruction, that input is available in B register also. I am taking this first thing ANL A comma hash 0F0H. So why I am taking this numbers means, look at this hash. So it is an immediate value. So first number must be an number, not an alphabets will be allowed. So that's why I am putting a 0 here. After that F0. So F0 is actual data, followed by H is indicates for hexadecimal. So actual number is F0 only. So F0, if you write it a binary, F it gets a 4-1. So 1-1-1-1 followed by 0 means 4 zeros. So 4140, this is the actual value for this FF. I am making this ANL A comma F0. So what happens? This 5A will be taken and that will be AND with, that is a logical AND with what is the value? F0, that is 4140. So what happened actually? So this 5a, if you write it 0101, this is for 5, and a you write it 1010. So that will be ANDed with 41 followed by 4 zeros. So if you ANDed, what happens? If one input is 1, the output is, the second input is passed as an output of AND gate. If the one input is 0, whatever than another input, the output becomes 0. So if you AND with 5a with F0, what happens? This a is masked. So whatever present, that will be masked. Here we have an F and here we have 5. So the output becomes this 5 update. So what happens? I get 5 0 as an output for this instruction. After that, I am swapping the nibbles. So swapping nibbles, this is swap a. What happens? So higher nibble becomes lower nibble becomes higher nibble. So here we have a 5 0 no. So it becomes 0 5. So the 5 higher digit go for a lower digit and lower digit 0 become for a higher digit. So 5 0 after swapping it becomes 0 5. After that I am storing that value. So move 50h comma a. So I taken a 5a and find that this result as 0 5 and that will be stored in 50h. After that, I am loading that value, actual value 5a. So move a comma b. So b already have a copy of 5a, no? So that will be moved to a. I am taking that input second time. Now I am performing AND with a comma hash 0f. So instead of masking lower nibble, I am going to mask here as a higher nibble. So 0f means 40 followed by 41. What makes the higher nibble will be masked, lower nibble will be passed. So here this 5a will be ANDed with 0f. What happens? This 5 is masked and this a is passed as output. So what we get an output? 0 is a is an final output. So that will be stored in move 51h comma a. So after completing, so I given as a 5a's input, I get a result at 50s 05 and then 51 I get a 0e. That means a number of ones will be available and 5 numbers of 10 will be available. So this is the end of the results. So this is the one code conversion. I am taking another example. Look at this binary to decimal BCD conversions. Look at this org0h. So initialize with the 0 location. Move a comma 65. So this 65 hexadecimal value will be moved to accumulator. Then I am moving this move B comma hash 0A. So 0A is an decimal 10 or hexadecimal 0A value will be moved to B. So here I am going to convert from binary to decimal. So just I need to check how many tens will be available. This will be a quotient, and how many ones will be available or a remainder, that will be a second digits. So I am going to take how many tens and how many ones. Look at this. That's why this is the input number 0 is loaded, because I am going to divide a 10 value with the numbers. So div AB, so this is then divide of A divided by B will be performed. A will be have a result of quotient and B have the result of remainder. So after division we have two results, one is quotient and another is remainder. Quotient will be available in accumulator, the remainder will be available in a B register. So after this, so this is the 65 divided by 0A we are performing. If you convert this 65 into decimal, what we get? We get a 101. So we are performing 101 divided by 10. So 101 divided by 10, we get a 10 is a quotient and 1 is remainder. So if it is a decimal 10, if you convert a hexadecimal, it will becomes A. So actual quotient is 0A and the actual remainder is 01. So I am storing this move 50H comma A. So the 50th location A register value will be stored. A register have value quotient, that is 0A. So this 0A will be stored at 50H. And 51 location I am storing this B register value. B is remainder. So remainder 101 by divided by 10, I get a 1 only. That 1 only stored in this 51 location. So after completing, I get 0A at 50th location and 01 at 51 location. Thank you.